Ever booked a flight online and watched that little spinner spin for what feels like forever? You're sitting there thinking, come on, just show me the price already. Now imagine you're the engineer who built that system. A user in New York wants a flight to Tokyo. Your code has to call 10 different airlines: Japan Airlines, Emirates, Air India, 7 others. And here is the problem: one of those airlines has a slow server. Maybe it's down, maybe it's having a bad day. What happens? Your user waits and waits, and then they leave. They go to another travel site. And here you just lost a customer because of one slow airline. But what if I told you there is a single line of Java code that fixes this? One line that says, I don't care if you are slow. I am giving you 2 seconds. After that, you are out. Today, we are building exactly that. And by the end, you will know the trick that every major travel site uses to keep their users happy. Hey everyone, welcome back to the channel. If you are new here, we break down complex system design concepts into stuff you can actually build and use. Today, we are tackling something every backend engineer faces: calling multiple external APIs and getting a response fast. We are building a Spring Boot microservice that fetches flight codes from 10 different airlines. But here is the twist: we are not gonna wait for the slow ones. You will learn what InvokeAll with Timeout actually does, how to mock real network delays so you can test this yourself, and the exact pattern that production systems use to stay resilient. This isn't theory. By the end, you'll have working code that you can use for your next project. Let's jump in. Let me paint you a picture. It's Friday night. You're booking a last minute trip to Tokyo. You go to your favorite travel site, type in NYC to Tokyo, and you hit search. Behind the scenes, here is what happening. Your server sends out 10 requests: one to Air India, one to Japan Airlines, one to Emirates, all at same time. Good so far, right? But then Japan Airlines is acting up. Maybe it's getting too much traffic, maybe their database is slow, whatever the reason. Their response takes 6 seconds. Meanwhile, Air India replied in zero point 0.5 seconds, Emirates in zero point 0.8. All others came back quickly, but your code is still sitting there waiting for Japan Airlines because you wrote a loop that says get code from airline 1, then airline 2, then airline 3. Or maybe you used a thread pool but forgot to set a timeout. The result? Your user stares at the spinner for 6 seconds. They think your site is slow, they blame you, they go to Expedia. You are only as fast as your slowest supplier. And in the real world, suppliers fail, network fail, servers fail. So how do we fix this? How do we tell our code, look, I want codes from everyone, but if someone's late, I am moving on without them. Now, before I show you the magic line, let me quickly walk you through how we set this up. We are using a Spring Boot with Java 17. If you have never used Executor Service before, don't worry, I'll explain every piece. First, we need to represent an airline. Super simple, just the name. In real life, you'd have URLs, API keys, all that. For now, we'll keep it clean. Then we need a task that actually calls an airline. In Java, when you want something to run in a thread and return a value, you use callable, not runnable. Callable. Because callable gives you back a result. Look at this. Our code task takes company and some travel info when it's called. It invokes solicit quote method, and that's our network call. Let's go to this. Now here is where it gets fun. We are gonna mock that network call to behave like a real airline API, which means sometimes it's fast, sometimes it's slow. So let's see what I did here. I added a random sleep between half a second and 4 seconds. In real life, you don't control how fast an API responds. This randomness is perfect for testing our timeout logic. Some airlines will reply quickly, some will take their sweet time, and some might just not reply at all. So before returning a code, we log how long this API will take. Alright, here it is. The moment you have been waiting for. This one line of code is the difference between a slow, frustrating app and a fast and resilient one. ExecutorInvokeAll method with timeout. But what about this executor? So this executor is fixed thread pool executor, a dedicated executor for IO tasks only. For 10 airlines, 10 threads are fine. In production, you might tune it. So let's coming back to invoke all method. This is not your regular submit method from executor framework. This is beast mode. You hand it list of tasks, all 10 airlines. You hand it timeout, let's say 2 seconds. And here is what happens. Java submits all the tasks at once. They all start running in parallel. Good. Then it waits, but it doesn't wait forever. Three things can happen. All 10 finish within 2 seconds. Great. You get all the codes. The 2 seconds run out. Java automatically cancels every task that's still running. Something interrupts the process, but let's keep it simple. This is huge. You don't have to write your own timeout logic. You don't have to manually track which tasks are late. Java does it for you. It literally says, time's up, you're done, next. But wait, what happens to those cancelled tasks? Do they just keep running in the background, eating up resources? Great question. Stick with me. So, invoke all gives you back a list of future objects, one for each task you submitted. Now you loop through them, but here is the thing, some of these futures are done, some are cancelled, and some might have thrown exception. Watch here how we handle this like pros. First, we try to get a result by calling get method. If the task finished in time, this returns instantly. No waiting because result is already there. But if the task was cancelled because of timeout, get throws cancellation exception. Perfect. We catch that and add a placeholder that's timeout. And if task threw an error, maybe the airline's API returned 500, we get execution exception. We catch that and add failed. Now look what we return to the user. 10 entries, some have real prices, some say timed out, some say failed. The user sees results in 2 seconds. They don't know some airlines were slow. They just know your site gave them an answer fast. They are happy, they book, you win. Let's see this thing run. Let me get this Spring Boot app started. I'm gonna hit this endpoint and provide start point, destination, departure date, and number of passengers, and most importantly, a 2-second timeout as request params. Watch the logs here. So we are submitting 10 code tasks with timeout of 2 seconds. You will see each airline task starting. Some will finish in around 3 seconds, some will finish in 2 seconds, some will finish before 2 seconds. But watch what happens at exactly 2 seconds. At 2 seconds, you see task cancelled due to timeout. Those slow tasks, they are gone, cancelled. And here is the response. Some codes with prices, some with timeout. The whole thing took 2 seconds. That's resiliency. And that's how you build systems that people trust. And guess what? The entire code, every single class, every mock airline, the whole setup is up on GitLab. Link is in the description. You can clone it, run it, tweak the timeouts, even break it on purpose. Nothing beats learning by actually playing with the code. Now you might be thinking, okay, cool. What if all the airlines are slow? What then? Another great question. Let's talk about that. If every airline is slow, you have got a bigger problem. Maybe your network is down. Maybe there is a regional outage. In that case, invoke all with timeout still helps. You get your answer in 2 seconds instead of 30, but all the answers are timed out or failed. That's when you need another pattern, the circuit breaker. It's like a switch that says if everything is failing, stop trying for a while, give the system a break. We don't have time to build it today. But here is the idea. If you see too many failures or timeouts, you open a circuit. For the next 30 seconds, you don't even try calling airlines. You immediately return a fallback response. Then you try again. Combine invoke all with a circuit breaker. That's how the pro developers do it. That's all for this video. I'll see you in the next one with a new problem. But until then, remember one thing. Always set a timeout. Your users will thank you. If you found this video helpful, please give it a thumbs up and subscribe for more technical content.